Hello, my name is Nidhi Pandey and I'm a technical marketing engineer with Palo Alto Networks. In this video, we will look at how to build a gateway load balancer architecture with VM-Series using Terraform scripts. Gateway Load Balancer service is a load balancer in AWS with L3 and L4 capabilities. It can be used to deploy centralized security architecture with VM-Series firewall. It provides capability to deploy and manage horizontally scalable VM-Series firewall and provide security controls and compliance check in your infrastructure. The benefit of this architecture is that it provides flexibility to deploy VM-Series in an auto-scale manner, which can horizontally scale up and scale down based on the metrics which are published by VM-Series firewall for CPU utilization or session count, etc. Integrating with Gateway Load Balancer enables maximum flexibility, scalability, and performance when protecting inbound, outbound, and east-west traffic. In the centralized model, customers can segment the application resources across multiple VPCs and have a dedicated security VPC where VM-Series firewall are deployed with Gateway Load Balancer. The security VPC centralizes the resources that multiple workloads can share. This provides hub and spoke architecture with transit gateway in place. You can also provide connectivity to on-prem network on transit gateway, and traffic between the spoke to on-prem can transit the VM-Series firewall for security inspection. To make it easier to deploy the Gateway Load Balancer architecture with VM-Series, we also provide automation with Terraform and CloudFormation template. You can visit our GitHub repository in this location and find our auto-scale CloudFormation template and also the Terraform scripts, which will bring up the centralized security architecture with application VPC, security VPCs, and VM-Series deployed. In this video, we will look at how you can use Terraform template to build up a deployment with Gateway Load Balancer. If you look under the Terraform scripts, we have two stacks, application stack and the security stack. You can also find the documentation in this page. So the script builds a topology like this, wherein we have a security VPC with the VM-Series firewall behind Gateway Load Balancer. And we also bring in the application VPCs behind an application load balancer. Now, before we get started, make sure that you have followed the prerequisite steps to have the right environment setup before you can run the Terraform scripts. You also need to deploy a transit gateway with the default route table association disabled, which you can use it in the scripts. So I'm going to be using a Linux box to run this Terraform script. I have already downloaded the scripts to this repository. So need to go to the Terraform directory. So once you get inside the Terraform directory, you can see that I have the application stack and also the security stack. So we need to deploy the security stack first. So let's go to the security stack. And this is where we have all our Terraform scripts available. Now, if you look at the steps mentioned, you would see that to deploy the security stack, you need to set the variables in the Terraform tf-vars file. Now, if I open this terraform.vars file, I have the access key, secret key, the region where I'm going to deploy my security stack. You can define the availability zones as well. The VPC CIDR, the AMI ID. Each region will have a different AMI ID. There is a command which you can run from the Cloud Shell to generate the AMI ID. There is the transit gateway, which I already have created. Now going back, once you have your variables set, you can run Terraform init to initialize Terraform. You can run Terraform plan to make sure there are no errors. If the output comes out like this, it means that the Terraform is ready to be deployed. Now let's go ahead and apply the Terraform. Once you enter the apply command, it will ask you for a confirmation. So you can enter yes. And this is where it starts with the creation of all the resources in your AWS account. This is going to take a while, but you can see that it's deploying the subnets, it's deploying the route table. I'm going to pause the video for a bit while it completes. Once the deployment completes, you can see the message like this. The output displays the deployment ID. So all the resources will be appended with this deployment ID so that it's easier to identify. These are the firewall IPs. The various route tables are deployed, and the endpoint IDs of the Gateway Load Balancer endpoint is also displayed here. Now going back to our AWS console, if you log into the region, you would see that there are two firewalls which has come up, and these have the same IP which we just saw. It is appended with this deployment ID. When we go to the load balancers, you would see that there is a gateway load balancer which has been created. And now we want to look at the security groups. There were two security groups which were created for the firewalls. Going to the VPC console, and we have 4 endpoints which got created, 2 for each availability zone. At this point, our security infrastructure is all set. So now that we have all our resources configured, the next step is to log into the firewall and configure the Ethernet 1/1 interface in both these firewalls. So let's go ahead and do that. We will be using the private key which we created earlier to log into the firewall. So I've already logged in. Go to the configure prompt. I've used the private key file to log into this firewall. You can check the IP from the stack which just got created, or you can also go to the EC2 console, select the instance, and you will see the same IP under the Elastic IP section. Let's go back to the console. Now here, use this command to configure the management access. I'm going to give some password for my management access. And once you have set the password, commit the changes. After the configuration is committed successfully, you can repeat the same steps for the second firewall as well. And now you are all set to access the firewall from web. So let's minimize this and let's go to the web console and try to access the firewall with the password configured. So this is the first firewall. Click on proceed, and I'm going to use the password which I just set, and we have the management UI up. So the next step in our document is to create the 1/1 interface and attach interface management profile to it. So let's go to the network interfaces section, click on interface 1/1. This is going to be a layer 3 interface. Go to the config section. We can create a virtual router. We can add a new zone, and let's give it a name as zone 1. Under IPv4, let's select DHCP and go to the advanced section. This is where you can go ahead and create a management profile. You need to enable HTTP, HTTPS. We will name it as management profile, and this will be used for the health check from the load balancer. So once you have made the changes, click on OK and commit the changes to the firewall. Now, once you have committed, the link state turns green. This configuration allows interface to behave as both ingress and egress, and also allows the traffic to flow through based on the intra-zone policy. We can repeat the same step in the second firewall as well. Go back to your EC2 console, and if you go to the target group section, select the target group, you will see that the two firewall status turns to healthy. At this point, our security stack is configured and up and running. The next step is to deploy the application stack. And before we can start the application stack, we need to make some changes to the Terraform variables file. So if you go to the directory under the app stack, you can find the variables file here. So let's open this file. I have already filled all these details, but you can see that I have all the services IDs populated here. These IDs can be found in the security stack output, which you just deployed, or you can go to the EC2 console and the VPC console in AWS to get the IDs. For example, if you want to figure out what is the service ID, you can go to VPC, and under endpoint service, you will find this service ID. Similarly, the service name can be found here. The route tables can be found under the route tables. Similarly, you can fill all the other IDs in the file as well. So now that you have made your changes, it's time to perform the apply for the Terraform, and it will deploy the resources for your application VPC. We go back to the console. We have made all the necessary changes. So I'm just going to make sure I write this again. I'm just running it as a sudo user, Terraform init. It's going to initialize the Terraform script, and now we can run Terraform apply. And you will be prompted to provide input. You need to enter yes, and this starts the deployment of resources for our application VPC. It's going to take a while, so I'm going to pause the video again. So now we see that the stack is complete and we have all the resources created. This is going to be the deployment ID, and all the resources will be appended with this deployment ID so that it's easier for us to identify. So let's go to the AWS console and verify all the resources under VPC. And you can see that there is an application VPC which has been created. Go to the load balancer section. We have an application load balancer which has been deployed in application VPC using the subnets in 2 zones. And this is going to be the DNS name which we are going to use to access from the web for our outbound traffic flow. Now, if you go to the route tables, we have new route tables which were created, the endpoint route table and the load balancer route table. So if you look at the route table for Internet Gateway, you would see that now these are the subnets for my application load balancer, and everything is pointed to Gateway Load Balancer endpoint. And this is similarly, if I want to look at the load balancer route table, it's associated with the 3 subnets, and the routes point to the endpoint. So this is the default route which got added. Now let's go to the transit gateway, and you would see an attachment for our application VPC. We should also have a route table created for our spokes or the application, and if you look at the route, it should point towards the security VPC attachment. All right, so looks like at this point, we have everything deployed. We have our application VPC in place. We have our gateway load balancer, the endpoints created, the endpoint service created, and we also have the route tables created. So all that was created using the Terraform script. Under the EC2 console, if you go ahead and see, we also have an application which has been installed. We can also create a second app VPC using the Terraform script. So for that, we will have to create a copy of the existing app stack. So let's make a directory for the second application stack under the Terraform directory. And if you look under the Terraform directory, you would see abstract and the abstract 2. At this point, we will have to copy the files from abstract to the second application stack. So for that, you need to enter this command. And under here, you will see that all the files have been configured. You need to make sure that the tf state file does not exist, because this is going to create the new resources. Let's go ahead and remove the previous state file. And now that we don't have any configuration here, let's also verify the variable file. And I'm going to make just one change here, which is the VPC CIDR. Let me make it 10.40. Escape. Let's go ahead and save the changes. And now we can initialize the Terraform and apply it so that we have the second application stack also deployed. It will prompt you to enter yes to proceed, and it starts with the deployment of the application stack. I'm going to pause the video here while the second application VPC gets deployed. Once the deployment completes, and if you go to the AWS console, you would see a third VPC created, and you would also see a new instance which has been added in the application VPC. If you go to the route table, we have the appropriate routes which got created in the application VPC, and we also have the load balancer which was created in the second VPC. Once the deployment completes and the target group is healthy in the application VPCs and also in the security VPC, we can go ahead and test the traffic flows. Let's test the inbound workflow, and for that, we would need to access the load balancer DNS name from the web. So let's copy the DNS name of the load balancer and try and access from the web. And we see some response. This is the IP of my instance, and we should see some logs in the firewall as well. So go to the monitor section, refresh the page, and you would see some logs coming in to the load balancer IP from the internet. You can further create sub interfaces on your ETH1/1 and map it to different zones and identify the east-west outbound and the traffic coming from the individual VPCs. I'm using a jump host to connect to the instance. If you send an east-west traffic via the gateway load balancer, and if you look at the logs will be mapped to the specific zones and get zone-based visibility. To summarize, we just saw how we use Terraform to build this centralized security architecture with Gateway Load Balancer and VM-Series firewall. Now every traffic inbound to the VPC will be inspected by the firewall, and every outgoing traffic from the VPC will be sent to the security VPC for inspection, and any east-west traffic between the VPCs will also be inspected by the VM-Series firewall in the security VPC. And within few minutes, we just saw how we use Terraform to build this complete architecture. This brings us to the end of this video. Hope you liked it. Please do visit our live community page to know more about VM-Series deployment in public cloud. Thank you for watching.